students, the purpose of this video is to continue our discussion on doing research and analyzing data. Now, we've already spoke about graduate students going to college and spending semesters in an entire course thinking about how to analyze data. So this obviously is a very quick, small overview, and I'm only showing you two possible methods to use to look at data and to gather some conclusions about the data. So if this piques your interest at all, I definitely encourage you to possibly take a statistics course and continue learning about all the other ways that you can properly conduct research and analyze your data. But the first method that we're going to talk about as a way to organize your data is a frequency distribution. Frequency is simply just how often something occurs. That makes sense because if I ask you, what is the frequency in which you work out, or what is the frequency in which you go grocery shopping? I'm just saying, how often do you go? Maybe how often do you go in a month? How often do you go in a week? How often do you go in a day? And so frequency can be measured in multiple different ways depending on the unit that you want to look at, whether that's days, weeks, months, years. Any type of frequency would be allowed. Now you can create a frequency distribution table. So I have an example here, the number of goals that are made in recent games. And you have this whole long list. And generally the first thing you want to do is go ahead and put those values in numerical order from smallest to greatest so that you can go ahead and make your table. So you see the table in the right hand corner. It lists out all the scores from smallest to largest value. And I go ahead and put those possible scores in the X column underneath a score. So I was able to get either a 1, a 2, a 3, a 4, or a 5. And then in the Y column, I list out the frequency. So how many times did I actually get that value? So I scored 1 goal twice. I scored 2 goals 5 times, and then so on. And so that when things are broken up in a table such as they are here, I can start saying, okay, I see that I'm more likely to get 2 goals than anything else, or I'm probably not going to get 5 goals because it only happened 1 time, and I can start to make conclusions. Now again, if you're performing a sound research study, you're not going to only utilize this data, but you'll perform multiple tests and find other ways to analyze your data as well. But this is just one of many ways to begin to look at your data. Here's another example looking at newspapers. Again, I have all the different numbers of newspapers that were sold across 10 days. And so if you look at my table, I have, all the different values there and the frequencies at which they occurred. But what I want you to notice is that there are some values that have a frequency of 0. For example, 19. There was no day that I sold 19 newspapers. However, when I create a frequency distribution table, I don't want to skip values. I want to make sure I go in numerical order, and so I'm going to count 18, 19, 20, 21, 22, and so on. And if there's a value that doesn't happen, I would list that as a frequency of 0. Now, another way to create your frequency table is to group your values together. So you create what I'll call intervals of values. So you see I have 15 to 19, 20 to 24, 25 to 29. And so I create those intervals, and then I say how many times does a value within that interval occur, and I list out its frequencies. The important thing about the intervals is notice that all intervals are the same size. So looking at the very first one, I have 15, 16, 17, 18, 19. That's 5 values. 20, 21, 22, 23, 24. That's 5 values. 25, 26, 27, 28, 29. That is also 5 values. So it's very, very important that each of your intervals has the same number of values. I wouldn't want one interval to have 5 values and the other interval to have 7. That table would be considered incorrect. So how do I go about constructing a group frequency distribution? So again, you have a bunch of data points. If you look at this long list of numbers, it's a little overwhelming. It's not telling you a whole lot of good information. So instead, we'll make a grouped frequency distribution. So we'll put the numbers in order from smallest to largest. And we want to think about the range of values that are considered. When you think about range, think about like if all of you were dancers and I said, there are a range of abilities in this class. What would I mean? I would mean that some of you are really great and some of you are maybe beginners, right? So the ability is kind of all over the spectrum. Same idea with numbers. I'm trying to see, okay, what is the range of numbers? What's my lowest and what's my largest value? What am I covering? What span of values am I covering? So in order to find the range, we take the largest value and we subtract off the smallest value. So in this example, the largest value is 18, the smallest is 1. So I do 18 minus 1, and I find out that my range is spanning across 17 centimeters of values. So then I'm going to look at my group size, meaning my interval size. How large do I want my intervals to be? Depending on your data, you're going to want maybe more or less intervals. I'm going to want my intervals bigger if I have a whole lot of data points, but I'm going to want my intervals a little smaller if I don't have a lot of data. So you're going to look at what your range value was, and you are going to divide it by the number of groups that you would like. I want to know that there is no special way to determine how many groups you want. It is truly up to you. So whether you want 5 or you want 4 or you want 10, you can divide by any value. It's all dependent on what number or how many group intervals do you want to have. So in this example, I want 5, so I get the value 3.4. And what we do is something we called rounding up to the simple value, meaning we don't want to have decimal intervals, right? That's not very useful to us. We rather just keep it as whole numbers. So we'll always round up. Now, this isn't following our regular rules of rounding, because 3.4 in regular rounding, I wouldn't round that up to 4, right? But with this, with intervals for frequency distributions, you will always round up if the value is any larger than the whole number portion. So if I got 5.7, I'd round that up to 6. If I got 5.1, I would still round it up to 6. So then I'm going to determine my start value and then begin to make my groups, as you see that I've done here. So I've chosen to start at 0, and I have group sizes of 4, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. And you'll notice that all of those intervals cover every single data point that I would have. And so I'm able to then count up the frequency at which each interval occurs, and I find out that to have a length between 0 and 3 centimeters, there was a frequency of 3, and between 4 and 7 there was a frequency of 7, and I continue on in that manner. Now, moving on to a different type of a way to show my distribution of data is stem and leaf plots. Now, I will say that I think this one is not generally used in research. I don't see this one used often. This is completely a personal opinion, but I don't personally see a lot of benefits to a stem and leaf plot other than being able to visually see what occurs the most. So in a stem and leaf plot, you split up your values. The first digit is considered the stem, and then the leaf is the second value. So for example, if you look at the number 32, the 3 is in my stem, and then the value that occurs after that, so whether that's a 2 or a 0, is in the leaf column. So quickly looking, I can say, okay, the majority of my values are in the 20s, right? But personally, I think that's the only value to the stem and leaf plot. And it can also work with decimal values here. So you see I have a chart of 2.3, 2.5, 2.7, and so on. And so same thing, I put the whole number portion in the stem and then the decimal portion in the leaf column. Okay? As always, I hope you found this video helpful. If you have any questions or concerns, please don't hesitate to reach out. And I hope you have a wonderful rest of your day.